All right, so let's talk about the process of actually verifying identities now. You have done some simplifying. The verifying is essentially the same thing, only they're going to get a little bit more complicated just because you can handle something a little bit more complicated because you've been working with these. Let's talk a little bit though. If you notice what it says here, to verify an identity means to prove or show that both sides of an equation are equal or the same for all values of the variable. So this information here, it says this is done by transforming the expression on one side of the identity into the expression on the other side through a sequence of intermediate expressions that are each equivalent to the first. As with other types of proofs, each step is justified by a reason, usually another verified trig identity or an algebraic operation. All of that to say that we are going to use the steps and the process to simplify. Okay. All right. So some tips. You've seen a lot of these already. If you notice, number 2 says when terms are squared, consider Pythagorean identities. Multiply to get rid of parentheses. Factor. We may have to do some factoring. We may have to add some fractions or multiply. Do some dividing. We know to change terms, everything into terms of sines and cosines. So the other main tip for this particular section when we start working on verifying identities is that we are going to work on one side of the equal sign. And basically what we are going to do is the process that we've been doing where we're going to show or we're going to simplify. The difference is that now we know what the final answer has to be. So in some ways, these problems are easier because you know where you're headed. You know where you're trying to get to for your final answer. So yes, it's important that you are showing me steps and process. I have to be able to read and follow that. So you're going to want to be able to read, write neatly and carefully and show all of those steps. But what we are going to do is find the more complicated side, and we're going to simplify that side until we get what we see on the right-hand side. And I'll show you a couple other little things that I'll expect to see as well. The key also is to remember, it sure looks like we are solving an equation because we have that equal sign, but these are identities, so we are proving or verifying this. So for this first one, what I tend to do also, and this kind of helps some people, is just to remind you, okay, we've got left-hand side, we've got right-hand side. Ultimately, we need to show or prove or verify that both sides are equal to each other so that we can say, this is an identity and any value we plug in will make this true. So we want to work with the more complicated side, which in this case looks like it's this left-hand side. So I want to distribute. So when I distribute, I get this sine x times secant x, and then minus sine x times cosecant x. For me personally, as much as possible, I don't even really look at what's going on the right-hand side until I get close to finishing. And then I want to see and verify, do I have the same thing on the left-hand side as I do on the right-hand side? So if I simplify and rewrite this sine x times secant x, then I'm going to rewrite that as sine x times 1 over cosine of x. And then that's going to be equivalent to sine x over cosine x, which we know is equal to tan of x. And then we have minus, and then we have sine x times cosecant of x. Well, those two are reciprocals of each other. So that tells us that we just multiply those and we get 1. So we get the tan x minus 1, and that's what we have on the right-hand side. That's what we wanted to show or verify that each side was equal to. So very critical last step of every single one of these verifying identities problems is to show me that you get the same thing on the left-hand side as you do on the right-hand side. So if you notice, I did not write anything on this right-hand side until this last step where I'm showing that this left-hand side, I'm going to abbreviate that, LHS is equal to RHS. Left-hand side is equal to right-hand side. Okay, all right, let's look at a couple more examples here. This next one's a little bit more complicated, but if you notice, it simplifies nicely. I'm not going to focus my attention on that, though. I've got to focus my attention on these tangents plus cotangents and all of that good stuff. So I see that we have a common denominator. So I'm going to rewrite numerator over my common denominator plus cotangent x over my common denominator. And then I want to focus my attention on each individual term here, and I want to simplify that to see what I get. So I know that tangent is, let's color code this. I know that my tangent is sine of x over cosine of x, and then that will be over my my secant x cosecant x. I'm going to rewrite that as 1 over cosine x times 1 over sine of x. Now, if I combine that together and I do keep it, change it, flip it, I'm going to have cosine x times sine x all over 1 times sine x over cosine x. And I see that cosines divide out, and I am left with sine squared x for this term. And I've got plus, so now I need to go back over and I need to look at this next term over here, that second term. So I'm going to rewrite this cotangent x as cosine x over sine x, and that's all over 1 over cosine x times 1 over sine x. And if I do keep it, change it, flip it with that, I'm going to have this cosine x times sine x over 1 times cosine x over sine x. I'm color coding here again. And if you notice on this one, the signs divide out, and I'm just left with cosine squared x. And I know by my identities, it's sine squared x plus cosine squared x is equal to 1. And that's what I wanted to show. So my left-hand side equals my right-hand side. Boom, done. Nice, huh? Let's look at some other examples. We're going to work through number 5 today on these notes. There's a big trick on number 5 that you have to make sure you're comfortable with and familiar with. But we'll get to that. All right, this next one, I'm still just really doing the same process as I was. I'm simplifying, but ultimately at the end I want to be able to show, okay, what I simplified to get is what I'm seeing on the other side. So I need to distribute. I see factor on the outside. I want to multiply that times both terms on the inside. So I want to multiply tan x times the sine of x plus tan x times the cotangent of x times the cosine of x. So this tan x, I'm going to rewrite as sine x over cosine x times the sine x plus, I noticed that tan x times cotangent x is just 1. So that is just a 1 times cosine of x. So that just leaves me with a cosine x, or cosine x over 1 here. So now when I simplify this, I'm going to make this a little bigger, give myself a little more room to write. So sine squared x over cosine x plus cosine x over 1. I see that we have fractions that we are trying to add, so we need common denominator. So I'm going to multiply numerator and denominator. You multiply by the same thing. So my common denominator would be cosine of x. So I'm going to multiply by cosine x over cosine x. So then that gives me sine squared x plus cosine squared x in the numerator all over my denominator, my common denominator, which is cosine x. I know that sine squared x plus cosine squared x is 1, and this gives me 1 over cosine of x. And I know 1 over cosine x is equal to secant x. And that is exactly what I wanted to show or prove or verify that it was equal to. So we are done with that one. This one is a little more involved. I think you've seen an example like this, but I want to kind of go through this example again, just to kind of help you think through it. So if you notice, we have fractions. We are trying to add them. So we need a common denominator. So it means this whole term needs to get multiplied top and bottom by 1 minus sine theta. And this term is going to have to get multiplied top and bottom. I'm going to kind of squish this in. There's not quite as much room as with 1 plus the sine of theta. So what we have then in our numerator here, we have 1 plus sine theta plus 1 minus sine theta. And then this is all going to be over if I multiply 1 plus sine theta times 1 minus sine theta. If I FOIL that out, I'm going to write this off to the side here. Notice also our signs add to 0, so I get 2 over 1 minus sine squared theta. And then I know that that 1 minus sine squared theta is equivalent to cosine squared theta. I don't know if it's helpful to do this. I think for some people it's helpful to see this as 1 over cosine squared theta to help you think about the fact that that's 2 times the secant squared theta. And that's what we wanted to show or verify. So we have indeed shown that this is an identity. These are equal to each other. All right, last example for what we are going to do now. And this is a really important problem. If you notice, I've put little stars and asterisks. I would suggest that you highlight this, arrows, all kinds of stuff. Remember the trick to solving this problem, because if you do not remember this trick, you're not going to be able to solve this problem. There's not really any other way that you can solve this type of problem unless you remember this trick. So what you want to look for, what you want to notice is there's a few things. If you look at the original problem, it looks like a proportion where we could like cross multiply and solve. But remember, we're not solving equations, so you cannot do that. But if you see a problem where you see that it looks like it's a proportion, probably more than likely this is this type. The other thing you want to look for is in the denominator on one side, you're going to see a 1 plus a trig function or a 1 minus a trig function. So that's typically what you're going to see. So wherever that is in your denominator, that's the side you're going to work on. So we are going to work on this left-hand side, and we are trying to find, we are noticing that it looks like it's a proportion, and we have this 1 plus cosine theta. So the trick is to remember to multiply by the conjugate. So you have these two terms here, this 1 plus cosine theta, and you have to remember what the conjugate is too. That's part of it. So the conjugate of 1 plus cosine theta is 1 minus cosine theta. Remember, to multiply by the conjugate, you keep the sign of the first term and you take opposite sign of what the second term is. So we're going to multiply top and bottom here by 1 minus cosine theta, because that's the conjugate of 1 plus cosine theta. All right, let's just kind of look at what we've got to begin with. I want you to realize that in some instances, you are going to want to distribute in the numerator. But in many instances with this type of problem, you're not even going to want to distribute here. I'll show you how and why in just a second. So if we FOIL the denominator, the reason why we multiply by the conjugate is, remember, we don't really actually have to FOIL, we just have to do FL. So we're going to multiply the first term, and we're going to multiply the last terms, and we get 1 minus cosine squared theta. And we know, I'm going to keep this as sine theta times 1 minus cosine theta in our numerator, but in our denominator now, we know that 1 minus cosine squared theta is equal to sine squared theta. And if you notice, in this case, if you had distributed here, you wouldn't notice this as clearly, but we didn't distribute, and so you can notice that there's this one sine term in the numerator, and that eliminates with one sine term in the denominator, and that leaves us with 1 minus cosine theta over sine theta, which is what we wanted to get. So we have done it. We have verified this identity. Okay. Now, just as a FYI, in some instances you may want or need to distribute in order to be able to find what will cancel out and divide out from numerator and denominator. But more often than not, on this type of problem, you do not even have to do this distributing. You want to keep these as those two separate terms so that you can see what might divide out. All right, hope that helps. So homework is for you to try page 9 in your notes packet. Some of those are simplifying problems, and then there's the beginning of some verifying identities. So you can kind of get started with showing and proving left-hand side equals right-hand side.